Hi guys, my name is Ilgvars Jēcis. I'm a founder and developer in a small company called Finotech. And I'm going to tell you about our experience with practical DevOps, how we do it in a small team of developers only company. About us, a company called Finotech, we provide build custom solution software for fintech companies. We have launched projects in Indonesia, Poland, Spain, also Latvia, who are coming soon. We are only 7 people right now. Everybody is only developers, mostly only experienced developers, 10, 15 years. So average age I think is something like 30. All of our guys, almost all of them have wives, families, kids, so really serious stuff. And this is a picture of our office. So I went to the office today at 9 a.m. in the morning. Well, nobody was there, so that's how it looks in the morning, our office. Just a small, simple stuff. Basically, our policy when we hire people is that no IT hipsters are allowed. And by IT hipster, I don't mean anything about your looks or your taste of music, but it's about your attitude towards IT. And by IT hipster, I mean guy who just read something on Hacker News that, oh, there is this new database called, let's say, CockroachDB. I think we should use it tomorrow and deploy next week to production. And these guys usually don't care about how we're going to support it. So we try to avoid IT guys like these at all costs. Typical projects we do, they're simple from technology perspective. We have web apps, some JavaScript stuff, back office applications for backend operations. Of course, some backend services, lots of third-party integrations, usually as in fintech, banks, payment gateways, credit bureaus, and etc. And of course, a database. So in our context, there's nothing really challenging from technology perspective of view. It's very kind of simple. You could call it just a basic, almost crude application. But real complexity and what we actually solve for the customers, we solve their complex business logic requirements and we solve their business processes. So what is actually a DevOps? So I just opened the Wikipedia. All the text really didn't make sense for me, but this picture kind of makes sense. Just because we are only 7 developers, there's no operations guy, no sysadmins, and no quality assurance people in our team, so we kind of sit somewhere here in that box just because we have to, not because there's some kind of DevOps movement in our company. And I also like this picture because very often when you talk about DevOps, we talk about development and operations, and very often forget about quality assurance. It's like a separate thing. This is another term by one of my friends, Jānis Solovs, who said this quote from Little Prince that Latvian is like, "Tu atbildīgs, ko tu pieredināji." First I thought it's like, it doesn't make sense, what is it? But when I thought about it, it kind of makes sense because whatever technologies or solutions you pick and you apply to your project, you become responsible for them till the end, till the support, till the end of the project basically. So at the end I think it's a very good quote actually about the DevOps. And most importantly, what our customers say about DevOps, and they don't say anything. They basically don't understand what DevOps is. They hardly understand what developers do. They most probably don't understand what operations do. And when it's a DevOps, there's like some kind of Frankenstein, so we never actually talk about term DevOps with our customers. And by customer, I mean the business guy, investor in that customer company, or a project manager, or a CFO, who actually orders a project from us and pays us the money. It's not the IT guys in the customer's company, so it's a bit different. So they don't really care. And what our customers care about is they want us to develop solutions quickly, cheaply, and they have to work. Cheaply would be easy to achieve if you work for free, but of course we are a small business, so we don't do it. And in order to make all these things to to work, we focus really on productivity. So if our team is productive, then we can basically fulfill all these quick, cheap, and it works keys. And I believe that applying DevOps mindset and practices, even in such a small company as we are, really boosts our productivity a lot. And how we do it? So we see DevOps not just like a stage where you have some working software on your machine and you have to deploy it to production or test or stage environments. We believe that DevOps mindset should start from the very beginning, from the maybe even before architecture, how you talk with the customers, how you get the requirements. But today I'll focus from the architecture point of view. So the way you define your software architecture definitely will affect how you're going to do quality assurance, deployment, and at the end how you're going to support it. So next is tech stack. What kind of technologies you choose definitely can affect those poor guys in the support. And in our case, those poor guys are actually we, because we don't have anybody else. So it's like you have quick feedback loop. You pick wrong architecture tech stack, like you very quickly get these issues in support. So we try to optimize or focus on a good choices in all these steps, because basically we are the same guys who do architecture, coding, QA, and support at the end. Which is, I think, very different maybe from big companies, and don't get me wrong, this is in our context, because we are a small company. In big companies, I don't know, even like Facebook, Google, it must be completely different, but I don't know anything about them.
They have support teams.
Yeah, and site reliability engineers and like thousands of people. But here is just how we, 7 guys, how we manage to do it. So architecture, actually in 100% cases we go for modular monolith architecture. It's like something between a monolith and a microservices. So what modular monolith is, it's still a single application which consists of multiple modules, but the key thing different from maybe the spaghetti monoliths, that each modules are really separate components. They have their own database schema, the same database connection but different database schemas. They have clear interfaces, they don't depend on other modules. So it's easy to replace and very easy to combine these modules together in the end product. So this, you could, at the end, perhaps you could even move them as a microservices if really, really needed. But so, what about microservices? They're so like fancy and sexy nowadays. I mean, we never have seen in our projects a case when we would benefit. What we think that microservices in our context is really a macro headaches, which means that if you have a team with 1, 2, maybe 3 developers, so what's the point to have microservices? We are not deploying thousands of machines, hundreds of services. Usually it's just a single application, some web, back office, database, and that's it. So there's no point to apply these microservices just because I can go and talk about them in conferences, for example. So yeah, we have never used microservices. We have read about them a lot. And when time comes, maybe we will use them, but so far, no need for that. Then about technology stack, there's one keyword which we apply, it has to be boring. Boring means it's stable, it's been running in production for our customers for years. It doesn't break with new releases and so on and so on. So boring means it's basically stable, predictable, and we know it. And again, like I've seen guys like, I think we should use Pascal in a backend and Clojure script in a front end, and I think this Recting DB looks really cool. We could do some async events to your backend. Well, come on, can you actually then go and support it in your at the end for the customers? Because our customers don't care about what kind of cool technology you use. They care that it actually works. So this is our workflow of choosing databases. So the simple, we really love Postgres. I mean, we love open source in general, but I mean Postgres just rocks. It's I think one of the best open source projects out there. Consistent releases, backwards compatible, very, very easy to set up and maintain.
Has hipster features.
Also, by the way, that's true. So yeah, we never had a reason to pick a NoSQL database because Postgres can do it. And again, our scale is not big. We have databases from 1 maybe to 50 gigabytes, and that's it. In some projects there's something like bigger, but Postgres really shines in this segment. And you can do full text searches, so no need for Elasticsearch. You can do key value, JSON, index JSON, some geographical data, all of this stuff. So why would you introduce a new technology component in your product just because it does this one thing, for example? Why would you choose Elasticsearch in order to search a list of 1,000 customers? So it doesn't make sense. So, and we basically discover every day some new cool features in Postgres and try to apply them. And the same goes for messaging queue. Very often, it's a simple case. We need to send a short message to notify client about some event. And yeah, it kind of makes sense. We should use messaging queue because it talks to external integration and has to scale and failovers and all this stuff. But really, you can do the same stuff in Postgres. And in our case, these events or messages, we are not talking about millions per second. There may be tens of thousands per day, so that's nothing for Postgres. And by applying some nice tricks in Postgres, you can build very simple, stable working queues. And nice thing that it all runs in the same transaction, so in case business process fails, nothing goes to messaging kind of queue, and you're all good. So we never have a trouble to go and look what happens in our ActiveMQ or Rabbit or, God forbid, the Kafka queues, where it went, what happened, why it keeps failing. We don't need it. And once you have these messaging queues, you need to think about scaling them, not scaling, clustering and backups. It's a nightmare, yeah. But I'm not saying they're not good. I mean, in our case, they're simply not needed, so we don't simply use them. Tech stack also, it's simple. I mean, we all know Java. We have been working with Java 10 and more years, so we are simply very productive with Java. I'm not saying Java is the best language ever there, but it works for us. So we don't use, let's say, Pascal just because it's pretty cool. Because customers not going to pay us because we spend 2 times, 3 times, or maybe even 10 times more time just to develop the same feature. And we kind of feel safe with Java. You can deploy it anywhere. They have all the libraries we need in the world, so it kind of works simply. And this step never actually happens because we only have guys who already know Java. And web development, yeah, that's I think a topic for another discussion, but it's really a mess. We have to do it. We do it, but we never enjoyed it. So far, we can stick with AngularJS and all these single-page application frameworks, but we're seriously considering going back to single-page, server-rendered websites for the public-faced websites. So yeah, it's one of the main reasons, for example, why our builds were failing, because some node version didn't work with something else. So clean workspace to start, and it works. So yeah, coding. And I think coding actually impacts a lot how the product actually how it's easy gonna be to support it at the end. And we try to do it again in a simple steps. So we build these small independent modules, with clear interfaces, so not even programmer could look at module interface and understand what's happening there. Minimize interdependencies. Again, we don't have a repository in company which has this commons stuff, like commons data stuff. And then you have problem. This one project depends on this commons version X and that on common version Y. And then you can't release it, there's some issues with interdependencies. That's why we sometimes do just copy paste. I mean, copying day utils like 100 lines of code, it's fine. You copy the day utils and day utils test and it works. It works forever. You never change it basically. In case some project requires changes, you change in that project. It doesn't affect anything else. So it kind of brings stability there's no interdependencies between projects. We don't abstract too much, the straightforward code, very easy to debug it and trace it. Very important when you have issues in production. One thing we actually do, because we handle finance data, we try to avoid any updates and deletes. So always just append only data. And it really helps in support. When you have some issues, you can easily trace what happened, let's say, with this account, why the account balance is X. Oh yeah, we can see all the transactions, what happened. So this principle, I think it makes sense to use. We avoid caching. I mean, once you bring in caching, you have more problems than before you had caching. Caching systems, Redis or something else, again, you need to think about how to make them highly available. So if you don't have CPU usage, let's say more than 80%, or disk usage too much, why would you need caching? In case you have more usage, maybe it makes sense to pay maybe these $10 more for one more CPU in your virtual machine, and that's it. So caching is like a last resort to improve performance in our case. But again, we don't have websites which are visited by a million people at the same time. So different context maybe than you have. And the silence that when you code, you think about how it's going to run in production is that when we have lots of integrations and other moving parts outside of our control, we know they're going to fail sooner or later. So we actually build in the code base things that they will just handle these failures. They will restart and take over after a couple of seconds or minutes. So very often we don't have any support tickets just because our code kind of handles these by ourselves to a certain degree. So I think that really helps to minimize the other areas like support issues. Quality assurance, very important step in a kind of DevOps. The whole mindset is, I think, because we are the only developers in the team, so we have to eat our own dog food, and we have to be a quality assurance guys as well. So what we build, we have to guarantee to the customers that it's going to run and run correctly. And what we have understood that unit tests are mostly useless. You write unit tests only for the piece of code which is pure algorithm. Let's say you need to calculate the interest rate. Yeah, you have input, you have output, nice, you write nice unit tests, and that's it. Once your code touches database or third-party services or anything else, you need to kind of like this ugly mocks and kind of tastes really bad, then we just don't do it. Instead, we do integration and functional tests. So when we write, we have these small modules, so every module has a suite of integration tests within that module. We have local database, it runs, and it runs all the SQL statements, whatever we can. Of course, we don't call actual third-party partners, but it runs everything, and it's like safety. We know it's actually going to run in production. If you have only unit tests, I'm pretty sure it's not going to run in production as you expect.
Do you store your empty database backup with your whatever version you run, or you have like some really old version of database backups from production and you run on those?
No, we always have these simulations of production data kind of scenarios. So you have a person who has an account, who had deposited X money, so we simulate this situation, then we run tests on top of that.
But it's still, in this case, it's still a synthetic test.
Yes, but if you would compare the data, the only thing which different is maybe created at value. So, yeah, we don't. I don't think customers would be happy if you run a unit test, integration test on top of production data. You forgot to configure that your SMS provider is actually mock SMS provider and it sends all the short messages. Can't tell more, but actually once we had this situation in different jobs, it wasn't good. And in order, usually say integration tests are slow. They run a lot of, they use database, so it's not a matter of seconds, it's minutes or even more. So because we have these separate modules, we can run all the tests in parallel. Java has this Gradle build system, the latest has very good features for that. So, for example, our tests, they simply set up temporary database in a Postgres, set up all the schema, all the test data, run all the tests, and then when they are done, they simply delete the database. So we can run whatever modules, tests in parallel we want. And that really kind of works for us. Yeah, manual testing, it's unavoidable. Once you have user interfaces, you have to do manual testing. I don't believe in Selenium testing. It can't tell you that your UI looks like shit, basically. And our approach is that if it works on my machine, it has to work on production. And it usually does. It's like, we told this team, we couldn't remember the case when in production something worked differently than our machine. Maybe one reason is that we use the same Linux versions and as on our production servers, but that's our nuance. No Windows in our office allowed. Yeah, and then deployment, I believe, has to be straightforward, easy to understand. You know what's happening, has to be repeatable and automated. But of course, before you deploy, you have to build something. And one thing we realized that my machine or my colleague's machine actually can be a build server. Very often we have projects initially where there's only one guy working. So why the hell you need build server for that? You can run your machine. It's the same as a Jenkins server, basically, the same technology. So for a while we are running our builds on our local machines. But before a project goes live, customer sees that we are ready to deliver something, they're ready to pay for this continuous integration stuff, work and servers, then we set up continuous integration. As I mentioned, Gradle 4 is awesome. It has these parallel build features and build cache. So just by upgrading one version, we reduced our build times 5 times, basically. So when I run build on my local machine, it's very easy. So now that's why I think Java is awesome, because you have these excellent tools around the Java ecosystem. Jenkins is okay. We have tried different cloud-based build solutions, Travis, Circle, CI, and whatever else. Always end up in some edge case, it doesn't support it, and it's difficult to do it. We usually stick with Jenkins, and with Jenkins file plugin, where you actually describe your build pipeline as a code, as a Groovy code. It's super easy. There is no need to go in Jenkins and configure anything manually. You check out your code base from Git, it applies the latest build pipeline you have defined, and it runs. And one thing, yeah, we realized that Docker sucks in build. One thing, maybe that's because we don't know Docker, we're not experts, but honestly we don't need it. The only thing we used Docker was to run the Postgres, so it kind of starts clean. Doesn't make sense, apparently. So we got these failing builds every morning, that something failed, the connection refused, so just restart and it runs. So one day we decided I just remove it, and we built this simple one instance of Postgres, which each module just launches their own database scheme and then just drops it. And since that day, everything, all the builds are green, only when developer breaks something. So there's no false fails of the builds. So I'm not saying Docker in general sucks, but in our context, in our build systems, we don't use Docker anymore. And this is, when we run build, it's a project around 100,000 lines of code, and it builds in 1 minute. So it's always run in a local machine, easy to do it in Jenkins and so on. And this is a look at our deployment pipeline. Nothing really fancy, just check out the code, build the modules, deploy to stage environment. Here always it stops and we go and check, always manually, does the website still looks okay, is the back office application working? Then we click approve, it gets deployed to production, and we just tag in GitHub in our release branch that it's done. Of course we have other pipelines for development use cases, but it makes sense to use it when you need it.
What is the picture?
It's from Jenkins build server, I'm sorry. I thought everybody knows Jenkins. Okay. Deployment, so when it's built, you have to deploy it. last picture showed we deploy it through the continuous integration, but again, it's okay to deploy from your local machine. If everything is automated, and there's no reason why it shouldn't be different than running from the continuous integration server. At least that's our experience. And from my experience, when we worked in one startup for 3 years, all the 3 years I deployed every version from my machine. I run builds on my machine. Our uptime was 99.97 through all the 3 years, and we had very, very few incidents just because something wasn't deployed right. Only once I confused deployed stage and the version production. So with enough discipline, you can even, if it's your one project, one-man project, no need for continuous integration deployment, just deploy from your machine. But it has to be automated. Yeah, I kind of told that the Postgres is really great, but one thing we suck at is actually deploying Postgres itself, making it clustered with masters and replicas. So initially we tried to use Postgres as a service. So the cloud providers usually have something, but we also found these small providers like Elephant QL, which can deploy Postgres on your preferred cloud provider, let's say Google or Amazon, instead of you. Configure all the backups, incremental backups, daily backups, replicas as much as you want, and you pay maybe $100 for that. So yeah, we try to not to host Postgres ourselves if possible. And very often our customers actually do it their ITT. Automated database migration, so we use Flyweight, we write automated scripts, so it's very risky to do database upgrades manually. It has to be automated and tested. And deploy daily, yeah. If you deploy daily, it's less painful, so just do it. Of course, daily means if you have to have anything to ship during that day. Sometimes we build large features, it takes maybe a week, then there's always a feeling after 1 week you haven't deployed, this is going to work. If you deploy 10 times a day, it's like just another deployment. So we try to deploy as frequent as possible. And if deployments cause no downtime for the users, why not do it? So this is how we deploy our projects typically. Just an Ansible so the automation tool. Everything is described, and we run one command, and it gets deployed to test or production environment. So we do it from local machines sometimes, and Jenkins do the same from Jenkins server. But I was telling everything is super simple. It's not like we're running all the application in one virtual machine. So at the end, it's a little bit more complex, but it's nothing super fancy. At the end, we have usually in projects a couple of virtual machines running Java and some Nginx, and we have load balancers and Cloudflare for DNS and SSL for free, by the way, and some Postgres and cloud storages. So this is typically our deployment structure. But usually deployments Ansible affect only virtual machines there.
What do you use for centralized log entries for service?
Log entries, actually. Or we look at the Google Cloud log solutions. I will tell about that later. So tools we like in deployment infrastructure is definitely Ansible. I know some people like Puppet and Chef. Ansible was the first tool I learned. It gets the job done, so I still keep using it. We definitely like Google Cloud. I think it's a good compromise of simplicity and capabilities. It's not the most capable cloud there. It's not the most simple, like DigitalOcean is definitely much more simpler, but it provides enough features for us. And Cloudflare, that's a nice solution when you need SSL for free. You can use Let's Encrypt, but there's some magic needs to be done, so we just use Cloudflare there. And provides extra services like DDoS attack prevention of web application filers and caching, so CDN for free and so on. And tools we didn't like or need, again, Docker. As I said, we are not experts, and I cannot tell customer that we're going to deploy our solution on Docker containers, and we can support you and guarantee this 99 point something uptime. Just for us, it doesn't make sense because we have usually 1, 2, 3, 4 virtual machines, so why would you need Docker for that? Kubernetes, it's a really cool idea, but again, would you deploy Kubernetes just to deploy 4 virtual machines? Probably not.
Isn't Kubernetes the same as Docker?
I don't think so. Names are different.
Approach is the same.
I think Kubernetes runs your Docker container. Huh?
Kubernetes is Docker cluster.
Yeah, it's going to orchestrate.
Yeah.
We tried to set it up, but after one day. And then Terraform, again, it's a nice idea. You describe your infrastructure and you run it, and it set up everything I showed in those previous pictures in a Google Cloud, all the load balancers, the virtual machines, and everything. It's nice, but in reality, we have to set up these virtual machines for customer once a year. And after a year, you're not sure is this Terraform script actually going to work, so you need to bug around, test it. So you just click the buttons in Google Cloud, and it works actually. And then Amazon Web Services, we just simply don't understand them. It's too complex for us. And one main reason why we didn't choose what the customer asked, actually we wanted to deploy first project on Amazon, but customer asked, how much is it going to cost me per month? It's like, that's where we stopped. It's like, so cost per read, cost per request, cost per blah, 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 blah. So in opposite, simple solutions like digital cloud, you have monthly cost per machine, and that's it. Like, and the customer is going to cost you $200 per month. So, okay, it's good. Or in Google Cloud, it's a bit more complex, but still you can calculate the costs. In Amazon, I simply don't understand how you can calculate the end cost for the customer. And these are not products which have to scale to millions or spike to millions of users. In our solutions, maybe you have at the same time 50 online users, and then 50 people working in the back office, so there's no spikes actually. So Amazon is not good for us. All right, and then support, that's where the fun actually begins. That's where you feel all the decisions, architecture, technology stack, how you coded, how well you did quality assurance. That's where you feel all the pain in support. And what happens in our case, we rarely have technical issues in support. I think, and just because we have very simple technology stack, there's one database and 2 virtual machines, and that's basically it. So there's no way for something to go wrong. It's very important for us to be able to deploy from issue request to production in less than 1 hour for critical cases. We did one project, we migrated one system to another during the Saturday night, so in the 6 o'clock in the morning we finished. And next day we woke up at like 12 o'clock and we had this list of tickets, issue tickets. I think it was customer fault, not ours. And we simply deployed every fix, like every hour we deployed 2, 3 fixes. And the customer then felt safe. They knew that we can actually do it. And maybe even it's better because if we didn't have any issues, they wouldn't see that we can do it. So yeah, fixing bugs, issues, and deploying them easy, quickly is very important. That we have full team, only a full stack developers really helps, because once you have any issue, web, database, infrastructure, Java, integration, SOAP, request issue, any of our developers can jump in quickly and solve it. So if you have team only with web developers, only with backend on database guys, and these database guys is on vacation, and maybe you can't fix the issue in 1 hour. Then what we do, extensive logging. We are crazy about logging. Every action in our Java code is logged. Huge volume for our number of users, but it really helps that we can go in our log management solution, enter client email or ID, and we can see everything he did in the last half an hour or maybe months ago. It really helps us to tackle these edge cases when something went wrong and we can't understand why just by looking at database data. And what we do also, data audit logs, so whenever something changes in database, we have another database entry which saves these changes to a certain degree. In case, I think for financial data it's just crucial. And yeah, one practice, which I sometimes do, Just come in the morning, take a coffee, and just open our log management solution. Just read the logs. It's amazing what you can find there. So it's so we can prevent and fix the bugs even before our customers notice them. So yeah, as I mentioned, tech-related issues are pretty small. This is actual app robot monitoring. It's been running, like, even forgot that we have this monitoring set up. You should send notifications to Slack in case there's some downtime. So in the last 6 months we didn't have any downtime. Shouldn't tell that, most probably. Yeah, and I think what are the hard things in support is writing documentation. Customers sometimes ask, well, why it's not documented? Where can we look at documentation? And first of all, we're just so lazy at writing documentation, we just hate it. Other thing is that documentation gets outdated like next day, basically. And third thing is that usually our code base is so simple that you can answer these questions in a matter of minutes. If you just look at the code, you can tell how it works. So why would you put your Java code in English in another document? It doesn't make sense. And how we avoid this is we tell customers, okay, we can write documentation, but you have to pay for this X amount of hours, and usually, okay, it's okay, just answer the question. Yeah, explaining customers why things work as they do. Very often customers order some things which they don't really understand, and we build them, and they after 3 months they ask why they are working like that. So in this case, all the logs and audit logs, they help us to show how this situation happened actually. Third-party integrations, yeah, these are one of the biggest pains. We have all these banks and bank gateways, SOAP and REST and TCP socket-based integrations. They just fail randomly very often. And this week, for example, one bank just changed the bank statement format, so without any notifications. Of course, we had some issues. So I don't have a good solution how to fix this. Just be on alert when it happens. It's very hard to avoid temporary solutions. When you want to deploy something really quickly, just do something quickly. Usually temporary solutions stay forever, so in case it's not a critical issue, you can still take enough time to do it properly. And I think the hardest feature in support is removing unused feature. So during support, you understand which features are used or not, based on some metrics or just understanding how the customer uses your product. And it's just always this discussion, I think you're not using this feature. Yeah, we're not using it. So could we remove it? Well, no, we paid for it, so maybe we'll use it later, and just keeps staying there forever. So also no good receipt how to tell your customer that you should remove these features, which is an extra bloat, and all the system just goes bigger and bigger and harder to support. So tools we like in a support is definitely Slack. So with every customer we have direct communications through Slack. Everybody can contact us anytime. Uptime robot, yeah, just sends notifications once a year when we have downtime. And then log entries is a place where we can go and look at all the logs. It helps with solving the issues. And this is an example of log entries. So I wouldn't say the UI is very functional, but it gets the job done, and you pay nothing for some amount, so it's very easy to convince customer to use it. But after a certain amount, maybe you pay $30 or $50 per month, and it still does the job. So that's one of the best tools for us. Yeah, and the final words. I would say that our project is like flying from Riga to Liepāja. Hope everybody knows what Riga-Liepāja is. And in order to fly from Riga to Liepāja, you don't need to build a spaceship. It's cool, I would love to do it, but we have this scope. So we only focus on building this, I don't know how it's called in English, like kukuruznik, or small planes. And it's cheaper, it's easier to understand how it works, and you know this thing can blow up in just in a second. And that's it, and you're done. So this thing, most probably, even engines run out, it will land nicely and smoothly. Not in Liepāja, maybe in Ventspils, but that's okay. So yeah, that's our context, that's our mindset in our small company. Yeah, thank you. Should I ask questions?
Yeah. First of all, really thanks for this
practical and pragmatic approach.
Yeah.
And yeah, the question is, you said that you have these independent components on the backend, yes? And the question is, how do you solve the situation when you need a common authorization or authentication service?
But it's a modular monolith, so it still runs in the single virtual machine, so it's easy.
Yeah, but are you still sharing the authentication component between the modules?
We have authentication on API layer.
So
all the
then
modules, they don't
on
care about the actual which user. We just pass client ID to, I don't know, loan application module. Or accounting module doesn't care about client at all. He cares only about transactions. So the authentication is only on top layer. That's it.
So in fact, it's still one jar file with the yes?
Well, now we have two jar files. We have evolved. But yeah, we separated back office application from backend.
Right.
Do you follow domain-driven design ideas?
Yeah. Okay. Yeah, I read the book. I have built before systems where we did it really wrong and it went really wrong. So I don't think we follow it 100% now.
What about the UI part? You said it's a headache. It's headache for us as well because people are with backend developers, yes, and
yeah.
One of the resort was, of course, Angular JS second version. What about you? What tools of Java do you use?
We used 1 point something because we knew it from previous jobs, and last month we started to use Angular 4.
Yeah.
It's a little bit better TypeScript, type safety, so you feel better at home, and it's a little more similar.
You like compile time checking?
Yeah, there is. It's not in production yet, so it's. But in the back office, for example, we switched to simple Ladin-based framework, which is purely Java. And for back office, where you have maybe maximum 100 concurrent users, no need for clustering and crazy availability, it kind of works. Yeah. So, but I think definitely we're actually considering going back to Spring MVC or GSP or something really basic stuff. Especially when you need marketing and search engine optimization, then single page applications really suck.
Question is, you mentioned monitoring. Which tool do you use for monitoring? What particularly do you monitor of deployments? What kind of specs are you looking for?
Sometimes for end customers. But as I mentioned, we have this uptime robot which simply pings some health endpoint. Am I up? And pings it maybe every 10 seconds or 5 seconds. Our customers very often use Zabbix, so they integrate. We kind of ask some metrics from our side. Yeah, but we don't have any Kibana, Grafana, whatever stuff. Yeah, maybe someday, but it's not really needed right now.
What is the maximum workload in your applications? Or maybe the most application that has the most users, and it's not just like, oh, we are doing deployment right now, or okay, we cannot do the deployment now because users are using, we have to wait like till lunchtime at least.
We never do that, we just deploy anytime. Because when we deploy, there's no downtime. Like, you can still use the system. Rare cases when you have very heavy database migrations, then yeah, we have to stop application, but we did it only once last year. So we simply deploy it. And that's it. Yeah.
Do you use like JSON features in Postgres?
Yeah, a lot.
So that's why you don't need to do the database
so
schemas.
When we build a feature, there was often the data structures what's going to be there forever. And then there's some
changeable
shit
stuff.
basically, some parameters coming from web. We don't have to use them. What's they going to even data type sometimes? So we just dump them in JSON. It works.
You mentioned replacing message queues with Postgres. Do you use full message queues for integration with third parties or external services? And how does it work?
Not really. All the integrations are either REST APIs, some JSON, HTTP posts, GETs. Thank God for that. But very often, the old school companies have SOAP. And I don't see how I should still put something in the middle between my code and the source, so just like call solve directly. But when we build application, at all these micro modules and end product, usually we realize we implement the business processes through custom built workflow engine, and all the integrations happen in backend, in the background basically, in an asynchronous manner. So, and then there's some queue-based stuff happening in Postgres to handle it. But in reality, there's no like millions of business processes running in parallel in business, like even in big businesses very often. So typically you have maybe a couple of thousand parallel business processes, so it's very easy to handle in Postgres.
You mentioned that you have a zero downtime when you're doing the deployment. That means you deploy to one machine, then you do the deployment to another one.
Yeah.
So, is there any chances that, for example, a user is still running their business process on the machine that is going to be deployed to?
It could happen that maybe some HTTP request failed for the customer because something changed. Definitely, yeah. But usually for our clients, these end customers are now not so-called high-ticket customers. It's okay if some requests fail, or even one customer just leaves because of that. So we don't really care about it. We should have.
Do you have something like a long-running process that creates a big transaction scope and then submit all into database?
Again, it's usually done through Postgres queues, and you have the state, is it done or not, and even if you kill all the machines, it's going to restart, and it sees that it's not done, so it starts processing again.
So you're doing more like PL/SQL development, or?
No, there's no stored procedures in Postgres. Like queue is just a table with some status and is it processed or not, and then use some locking tricks in Postgres to fetch the next job you have to do. You can scale it across two jobs. Yeah.
Your slides have some controversial statements, but one of the things surprises me. You told that unit tests are not useful. The question is, how quickly you get a response about some failure in integration test or functional test, and in what stage it happens?
Yeah.
In development machine or in CI?
We run, of course, when we develop, we write integrations tests in a framework called Spock, and do some code. I'm sure it kind of looks okay. Then I just run a test. And in case it's a small independent module, usually it's from 4 to 10 seconds. It's not like instant as like pure unit tests will do it, but I'm okay. It's 4 second or 10 second feedback. The end product, which connects all the modules, they sometimes test around 20 or 30 seconds. So we try to test all these modules independently as much as possible.
So integration tests are run on local machine,
but
functional on CI?
No, everything runs on local machine.
Even functional?
Honestly, I don't know the difference between functional integrations. So
functional takes more time.
We can make them longer. Some threads leave. Yeah. And,
which development machines do you use? The hardware specs?
Hardware? I think most of the guys have Linux machines, usually 8 to 32 gig RAM. Some SSD disks. Yeah. Well, it's not bad or super expensive machines. I just bought a desktop for 700 euros with some Intel i5, 32 gig RAM and PCI Express drive. Really boost things, like 700 euros. If I can even save 1 hour per month, it's okay. Yeah.
I do agree with you that there is no need to complicate things where there is no need for complications. So in your exact setup, it works for your size of company and everything. But the question is, do you ever feel like it prevents you from taking up larger projects where you could, I don't know, hire more developers and things like that? Does it actually stop you from considering that larger scale, larger size of projects?
Yeah, I would agree. We're not ready to go to, let's say, Barclays Bank and tell that we're going to build you a new banking core system because we are not capable to do it. Thing is, I personally like to work in a small company with no more than 10 people. And because we are so small, our also projects are usually very small, so we try to keep us in this environment just because we enjoy it. We're not going for scaling.
Fair enough. If you're not planning to grow,
Yeah.
then then why complicate things?
Isn't it super boring?
Well, we have other things to do besides working, so now it's okay.
But what, for example, happens in case if clients comes, okay, I have a project with you, now I want to scale this project more, and we are going,
Yeah,
let's
then
say,
we'll do
like
it.
worldwide.
Yeah, if they're ready to pay for that and do it, yeah, we will do it.
Let's do a few last questions.
Last one.
So, how many products at the same time you are supporting now? How many up and running systems, like live systems?
Yeah, I think for now it's like 4.
And what happens if 3 of them crashes? Not crashes, customers come and complain. 3 at the same time. What do you do?
It's like 24 hours per day.
Oh, okay.
And sometimes we work long hours, yeah. It happens.
Okay.
Okay, thank you.
Thank you.